Okay, welcome back to the channel, guys. Today we are going to do a quick video on how to design a circuit on breadboard from your circuit diagram. And as you can see, we've got a voting circuit breadboard that we're looking at today, and we've also got a little task list in the right hand side which will guide us through the process. So first things first, task list number one, identify your ICs. Now, you already know that this is a voting circuit as part of the digital logic assignment, so we would have gone through the logic gates and you will have understood the design process involved with the circuit. And so we can see that there are two different types of logic gate in this circuit, the AND gate and the OR gate. Now, this is important because when we come to physically design this circuit with a view of building it on breadboard, we need to use two different types of chips. You cannot get a combination of AND and OR gates in a single IC package, integrated circuit package. So if we look down here, we can see there's two different types of ICs here. So we've got the 7432, which is the OR gate package there, and we've got the 7408, which is our AND gates. So when we look at the circuit slightly above, you'll be able to see that the first three AND gates come from this chip, and then your latter two OR gates come from this chip. And again, we've already gone through the pinout diagrams, but you can see that these certain gates are located within these ICs, and the inputs and outputs correspond to specific pins. So if we jump across to point number 2 where it says label your circuit diagram. Now what that means is we're actually labeling up the logic gates, and we're going to label up the inputs and outputs, and this will make it way easier to design and draw on our breadboard once we know our specific inputs and outputs. Now to do this, we need to reference the gates and also the ICs and the pins of these chips. Now what I prefer to do is label up the individual logic gates on the circuit diagram and marry that across to what we've got over here. So it basically means what we're going to do now is, on our circuit diagram, because that's an AND gate, we've labelled it number 1, which corresponds to this one here. We can see that the inputs to this AND gate are pins 1 and 2, and the output of that gate is pin 3. And we're going to transfer that information up onto our circuit diagram. So we know that this will be pin 1, pin 2, and output 3. We're going to do the same for the rest of those gates, for gates 2 and 3. So 4 and 5 are going to be inputs on gate 2, 6 is going to be the output, and then for 3 we've got 8 and 9 and 10 as inputs, and 8 is an output. Just like that. We can do the same for the OR gates, gate 4 and gate 5, and then we've got 1, 2 and 3, and then for 5 we've got 4, 5 and 6. Now this is particularly useful when we start looking at connecting the logic gates of the 7408 to the AND to the inputs of the 7432s, because here we will have the output of logic gate 3 or logic gate 1, which is pin 3 here, will be wired into the input of what we've labelled as logic gate 4, which is pin 1 of the OR gate there. It just makes it easier once we've transferred our pinout diagrams to our breadboard, which is nicely prepared here. So we've done point number 2. Then it asks us to sketch components such as your ICs, switches, resistors and LEDs, and we're going to sketch these onto the breadboard. Now I always recommend that we do these as accurately as possible, so when you can see it accurately, you can just replicate that and build it as is on your breadboard. Now the other things that we haven't spoke about much is obviously you're going to have 5 volts coming into the circuit, have a ground to ground the circuit. On the input side we've got 3 switches, and we've got some pull up or pull down resistors. I can never remember which way around it is. We've got those we need to factor in, and we've got our either logic probe output or LED indicator, which will indicate when the circuit is giving an overall output of logic level 1 or logic level high. So first of all, I'm just going to put some labels in, because we will be connecting this up to a power supply and testing it. So first things first, let's get some power and grounding. So straight away we know that we're going to have 5 volts positive, and then we're going to have 0 volts at ground. So by putting these in, we're just doing the basics of getting the circuit ready to be built. Now when we build these, we'll be using a kind of dual inline switch block, which is a kind of like a dip switch 4-way, I believe it is. 1, 2, 3, 4. So I'll take 4 dots. So we're just going to roughly sketch that in there. Essentially what that will be is just a little switch block that will bridge the non-conductive gap in between the breadboard right there. Now what you can do is, if depending on how much time you've got, you can make it look all fancy and put your 4 little switches on there, which will correspond to the obviously incoming and outgoing signals. And then probably more importantly, we'll have our pull up or pull down resistors, and they are going to go between these switches and ground. Now all we need to do is sketch these in. They're not going to look perfect, but it will give you an indication of where they need to go when it comes to putting your circuit together, just like that. Now you can draw them anywhere. What you'll probably find is when it comes to completing this circuit and drawing them in, you may need to wire them slightly further down, so you've got a bit more room for connecting the signal wires in between the switch and the resistors. So around here, give yourself a couple of spaces to connect them together. And then what we're also going to need is a couple of wires that will join the 5 volt rail to the top of your switches, just like that. So that's kind of taking care of the input side of it. If we go back up and look at our circuit diagram again, we've now got kind of the business end of what's going off here, processing side. Now for that we are using these two ICs, these 2 logic gate chips, and they've got 7 pins either side, 14 pins in total. So what we're going to try and do is give ourselves plenty of room, but actually sketch these in here. And this is where you're going to connect your wires up into those chips. So we're going to make sure they go across 7 ports of the breadboard. So 1, 2, 3, 4, 5, 6, 7. And then back across the other side. And just good practice to label it up the correct way. Same again with the next one. So across there, 1, 2, 3, 4, 5, 6, 7. Up across there and back along this way. And put the little thing on the top to indicate pin 1. Put a little dot there as well for the same purpose. Now what we're also going to do is, as we've labelled your circuit diagram and our pinout diagrams have got labels on, we're going to do the same thing for these to make our life easier, so we know where our wires are going to go. So we're going to label these up following the pattern. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Same on this one. And what this will enable us to do is quickly and easily identify these pins of the ICs, so we can simply use the numbers from the circuit diagram above and map it straight across into our breadboard. Now what we also need to do is make sure we have VCC and ground connected for both of these chips, otherwise Doesn't matter how neat and nice your wiring is, it simply won't work because they've got no power going to them. So straight up to 5 volts for pin 14, and then down to ground from pin 17, which is the bottom of here. So pin 7 ground, pin 14 power. Now what we'll do, because it is on the tick list, is stick our output side in, and this is going to be from pin 6 of the OR gate, or gate 5 as we've labelled it as. Now on our 2 chips, to easily identify them, you should really put the numbers on so we know which one is essentially full of OR gates and which one's full of AND gates. The 7432 is the OR gate, and this is the one that's going to require the output from pin 6. Now when we say output from pin 6, what we are going to do is essentially use a wire. And we're going to go up. I'm going to try and make it as neat as possible so it's easy for everyone to follow. Up, out and across all the way over here. And then what we're going to do is sketch in our LED, or light emitting diode, across here. Now again, we're bridging the gap between top and bottom of the breadboard really, and then we are going to go down to ground via a current limiting resistor of roughly about 180 to 200 ohms, doesn't really matter which one's which. So that then is the output stage sorted, along with the input side sorted. So we've got 5 volts going into the circuit here, that then gets carried down. Obviously you've got the conductive material underneath the breadboard carrying that through to the switch, and then we've got the pull up or pull down resistors in between the switch and ground. So essentially what will happen is when we flip one of these switches, we'll either get a logic level 1 or a logic level 0 at this point, and we'll then start to wire up the wires or the input signal going into the corresponding input pins of the logic gates. If we do that in the correct order, we will then be able to get the circuit working as simulated above, like that. So what we're going to do first is we have got